Hi, everybody. I will admit, to start with, this is not the best of my thoughts. Honestly, none of them are really the best. But I did present our RFM. That was certainly the one the most people looked at gave me feedback. This one is kind of unhinged thoughts about API reviews. So, put your hand up if you've heard of a company called Tom. MuleSoft? Salesforce. MuleSoft, by the way, previous company. So API management tools have really kind of started, very recently. And they present a really different paradigm of how developers do APIs. Now, previously, actually still API management is not that popular. We actually see most APIs being deployed in like frameworks. You've got your Django, you've got your Laravel, you've got your whatever, Spring Boot, whatever. You've got your framework of choice, and it just has tools to make RESTful API endpoints. But API management is this really weird thing that developers are now doing. So essentially, it provides this wrapper around an API. So we have years of all these API development tools, years of these API hacking tools, and developers have now messed it all up because they've gone and bought API management solutions. We used to have things with Swagger. You've heard of Swagger, people handle? RESTful APIs? GraphQL? Okay. Fair amount of knowledge about API. And the reason why this is kind of my unhinged type of stop doing API management, APIs were never supposed to be managed, is because they kind of work. APIs are very much developed as this amorphous blob of like something that gets created over time and through a lot of technical depth. So a bit about me. My name is Dr. Paxton-Fear. I am a part-time lecturer at Manchester Metropolitan University. But if you know who I am, it's not for that. It's not for my very mediocre academic achievements. It's actually because I make YouTube videos, teach people how to hack. I do bug bounty hunting, and I work for an API security vendor called Crucible, and I do technical marketing, which you may be surprised to know nobody wants to talk to you if you say you're a YouTuber or in technical marketing. It's the easiest way to stop literally anybody who's talking about something. But I make a lot of API security content like this. So first of all, what is an API for those who maybe aren't aware? An API is a type of application that's really not designed for humans to consume. It's really a type of application that is designed for other applications to consume. I really like Postman's way of thinking about it as like a waiter in a restaurant, a way to serve as a communication bridge between you and the kitchen. So the idea is that other applications will consume these APIs, and oftentimes what that means is you'll have like your mobile app, you'll have your Android app, your iOS app, your desktop app, and because developers are lazy and don't want to write the same code 4 times, you can blame them. They write one API and then they write connections to it. Basically, lessons the workload on their server. APIs are essentially the building blocks of modern technology. Now, some you'll see, like things like the developer APIs, well, Twitter APIs, for example, but a lot of them actually are hidden from like your view, and they're not really supposed to be massive, but you can still see them. And the whole idea here is like this microservice architecture. It doesn't matter if, we're making a social media application and we change what CDN provides our video player, right, or the video file for our video player. We can easily flip switch on the video player service and then it will just switch over. Realistically, it never actually works that easily, and they actually aren't very well microservice either. So why do developers really like APIs? Well, there's a few reasons. One, you write it once, you use it lots. So you write one piece of code that you use over multiple different applications. They're standardized somewhat. There are API standards like RESTful APIs, but anybody who knows anything about RESTful APIs probably knows this poor guy whose PhD thesis was on RESTful APIs, whose idea of the whole idea of RESTful this big, great, stateless service that we completely ignored. massively ignored his actual work, and just took the name, really, and standardised the API endpoint name from it. But they are somewhat standardised and somewhat predictable, and what this means is that a lot of APIs, like developing APIs in your application, is all built into existing framework. So for a developer, it's not a big lift to actually start building an API. And also they're widely supported for consuming APIs. So if you have an application and you, say, want to let developers build up your application, you can very easily make it public. There's a lot of ease of integration. It's very easy to get started. It's very predictable. You have documentation. They can be quite scalable as well, especially depending on how you build them. And they're really friendly for other developers. Developers know what they're getting when they're getting themselves into it. Yeah. So previously, this is really how APIs were developed. You put your developers, whatever backend framework they're using, and you Google, PHP, Laravel, RESTful APIs, and you get the documentation. So here is how you very quickly implement that API. And this is great. This is really great for getting them started and getting APIs building really quickly. Unfortunately, it caused one minor problem, which is YOLO APIs. You want a new endpoint? Great one. Not sure what you might need from an endpoint? That's fine. Just output everything. Social security numbers? That sounds like something to be in the API. You might need that. Credit card data? Also, you might need that. What if, in the rare occasion you decide to add that to the UI? You might need it. So, we'll just write everything. Not sure if something should be public. It's undocumented, so nobody will figure out how it works, right? Not using an endpoint anymore, don't bother deleting it. You might need it later. Hotel Trivago. Right, like a lot of APIs end up in this weird blob that's been slowly added to over time, and it's like a tumor where it just grows and grows and grows, and then suddenly someone comes down to your office and goes, by the way, we have an API group? How? And you're like, well, I don't know. Like, what API is it? And this kind of leads to this ad hoc security of APIs. So they are really ubiquitous. They're very much led by development teams. And it can be really hard to tell the difference between legitimate activity and an attack, because they look essentially identical. A lot of developers will assume that an API that is available to the public is internal, because it's not documented. Well, that's just not really the case. API endpoints are deployed every single day, and because they're developer-led, most security teams have no idea what they're doing. Absolutely no clue. Even APIs that are supposed to be public, that are designed that way and designed to be secure, don't really have documentation. Certainly don't have any security people on the team watching them. And it puts this really weird unknown attack surface where a lot of security teams know they have an API somewhere, but have no idea how many endpoints it has, whether or not it's held sensitive data, etc. So a lot of people saw this general problem and thought, okay, we'll solve one at a time. Let's solve the documentation problem. So if you want people to use your API and not be a wasted development effort, you want to make it public. A lot of the kind of business model we've seen from Reddit and Twitter is you make the API free, there's a bunch of services rely on it, and then you charge a lot of money to use that as an enterprise service. It's essentially a way of you need to tell developers how it works. How do you use this API? How can you implement it? Now, any API that is public is not necessarily private, whether or not it has documentation. A lot of people will go, it's documented, it's developer, it's public. It's undocumented, it's public. It's private, and it's internal use only. Not necessarily the case. So, as a way to kind of solve this problem, there was this creation of this API ID with Postman. And what Postman allows developers to do is create a tab and do a call it like IntelliJS in terms of its system. It's essentially an IDE for people making RESTful APIs. So it doesn't work with programming or a specific language. with. It's literally just a nice little front end for a TCP request. And they also managed to sell that, by the way. That's their business model. And it essentially allows you to test RESTful APIs as you develop it. Their main market is like developers who are making APIs. But the really cool thing about it is that you can start to export reflections. Once you make your API and have a little API in place, you of course are a developer, so you don't write any documentation to go with it. Postman allows you to just generate that. So problem solved, there's documentation. The idea is you take your little collective parameters, send to your developer, and they can use it now in Postman text. Not quite the same as project documentation, but it kind of provides like an area for them to work in. And this is where something like Swagger comes in. So Swagger and Postman are very similar in what they provide, but for two very different markets. So Swagger is the same idea, literally your RESTful API. It's primarily meant for people to consume. It's so you can list, hey, here are all my API endpoints, here's all the stuff you can do with them, here's the parameters you need, here's the API key you need, go find it. And I work with something called Open API specification, which is essentially this agreement standard of how we should present information in an API. And this gets us halfway there, right? The endpoints we know about are documented, kind of, and they might or may not be public, but it doesn't really solve a lot of other problems for developers, which is where to pull graphs. We've got a board meeting coming up, where are my KPIs? And this is really where API management comes in. So API management sits on top of the API. You might be thinking, this sounds very complicated. And you're right. It is. The API management layer tries to combine a bunch of different services into one area. This is an example from Azure, but there's lots of other API management tools out there that provide this like next level interface above an API. And here's the kind of idea. You have your consumer, you have your firewall, and then you have your API gateway. Now your API gateway does everything API, both on the architecture level, so like how you design and develop APIs, and then at the bottom on the like statistical, analytics, and starting to include security policies in. It usually includes some kind of design workshop feature where developers can write APIs. It usually has support for things like hashing and scaling, so APIs can get bigger and bigger and bigger. And it usually has some kind of security policies you can put on and off. Now, depending on who serves your API and how much money you pay, what those exact security controls are depends. But broadly, it essentially sits between your API and your actual firewall. So the idea is to start off using an API management tool with scaling, statistics, and security. One, you design your API with an API specification. This is your test-driven development of APIs. It's spec-driven development. And you might make your API design available to others. Two is you connect your API to a data source, so the database, MySQL, whatever. Then you deploy the API, set up any security policies, and then integrate with existing services. You may notice a slight problem there, which is that all of our APIs are not necessarily in a design state. We already have them kind of rolled out, people using it. So what you have to do with your API management tools is often throw it away and do it the MuleSoft way or the Tom way. And that's just kind of what makes it a difficult sell, because while it can include a lot of really good stuff around like getting statistics, load balancing, and performance data, and you can see how quickly your API works, stuff that developers like because like quarterly board meetings, but not necessarily something the development team actually wants to completely rewrite the API. There are ways around it, but it often requires like a complete rewrite API. And the actual development tools, you get the Tom Design, the MuleSoft Design Center, I don't know what Tom does, but at least it usually requires completely moving it. But it does make security policies easier, because instead of developers having to develop their little APIs and write if statements, they don't have to. So a lot of them provide a simple checkbox interface. You want an IP blacklist to be enabled? Actually, is it a whitelist? Does it have, I don't know, like a lot of JSON coming back? Yeah, we'll pick that one. And this is really, really like appealing for a lot of security teams, right? Because you don't know what the API like shadow mess is underneath the hood. The developers probably don't even either, to be fair. But it means that if they're deploying something new, you can just get them to check boxes to implement whatever policy you want. Oh, check it out. The problem is that while its security policies make easy, the kind of problem with API security is often not covered by these, like at all. So there's a lot of API management vendors out there. Apogee, owned by Google, MuleSoft, Pong, and Azure, they all kind of target slightly different markets. If you are already using Azure, you will be told the Azure API management tool, which is popular. MuleSoft, if you use Salesforce, that's going to be your one of choice. And Apogee, same to do with cloud products, right? Like, it's very much based on where your cloud is kind of ready by your API management tool. And in terms of what features you get, that's broadly the same. Especially from a security point of view, they have policies you can pick and really do it. The question is, does it actually work? Like, is this solving the API security problem? Kinda. It kinda works. It mostly works. Because to solve some problems like documentation, graph, architecture, design first, all of those nice buzzwords that if you go to a developer conference and sit in there for more than 5 seconds, you will hear them all say. It does solve that. It provides this nice, unified place for all of the API development stuff to go into. It very much creates those nice graphs that shows where the loading is. Does it solve API security? Well, Marie Kondo wrote a very famous book called The Life-Changing Magic of Tidying Up. And then recently she had her second child and so she's given up with it. Which is kind of roughly the spot where API security is, to be fair. Like, the expectation is there. This tool is going to solve all of our problems. Why? Because the marketing of that tool told us. And we paid them a lot of money to solve all of our problems. And it's just not the case. Security is far more complex than just switching on and off elements. Like, if you go back to those security policies, what isn't covered in there? Is this logic error? Payment issues? Regulatory compliance? GDPR is zero about personal data in there. We don't have any control over authorization. We only have a way to turn on authentication, not only OAuth, whether you data like you. And you can kind of see that this is super appealing. Like, all you have to do is check. Security is done. In reality, we all know that security is not quite that easy, no matter how good their marketing is. So yes, it solves some problems. It shows them nice graphs. It gives them a feeling of control over an API. But does it solve API security? No. And one of the huge reasons why is because the way APIs are made 5 years ago and the way APIs are made in the API management business, because really only got popular maybe in 2 years, are such different development paradigms. So if you think about your REST kind of setup with something like Django, you would go there and create your nice React front end. You have your MySQL database and you write your API endpoints that you then put into React framework. If you want to move to API management, you're going to jump into Java and you're going to write it again. And it really doesn't help those legacy APIs. New APIs, sure, great, checkbox, whatever. Older APIs, it's just really hard to get them to go from one side to the other. If they already have it, excellent. If they don't, it's such a massive job. And yeah, there are ways to it. You can do it for a proxy. You can kind of hack it and cheat it. But the problem is, it doesn't actually fix problems. We see API, but you can see API routers literally everything there. It hasn't fixed literally anything. And, I mean, just look at the Snowflake routers that came out, literally, last week and the week before, right? We are not solving security by using, essentially, a dev tool, and it doesn't matter what they promise us. The problem is still that any API has so little security overhead to it. On the best case, your developers might keep that tested. In the best case. In the worst case, they are just deploying whatever they like. They've got their CI/CD pipeline, they're part of the pipeline, that's it. Problem solved. And it's just not enough to stop API security problems. API security problems are so much about the logic of an application, the way your authorization is built, the way you interact with third parties. You've got upstream and downstream connections, and you've got internal processes as well that all connect together. But if you don't have security oversight when the developers are tapping away actually writing the things, you do not have oversight. It doesn't matter what kind of tools you're developing and using. So I promise you API hackers or API management for API hackers. So how do we hack the API management layer? Well, it's not really that difficult, to be honest. When we see that somebody is using real software or actually, we want to test what we know the kind of default policies that those gateways provide. We want to test, whether or not we can access neutrality in the editor, whether or not we can get a lot of responses back. But that's just regular API testing. There is nothing special about that. There is nothing special about how you hack API managed API versus regular APIs. We won't even bother testing block lists and PDOS. We won't even scope for the client anyway. So the work changes nothing. Okay. It's probably not quite fair to say that work changes nothing. API management is really solving a different problem. And API management is really not about security. Security is kind of this weird little afterthought that they thought they could sell. But API management is far more about handling the load and scaling and all those other problems that actual developers think about every day. And how they deploy things public facing and how they manage that command. Especially if you think of an organization, maybe a power company that provides the API to their your actual individual solar panels in your house, and that's done through an API. That's kind of the target market. It is not actually solving security problems. And while it does add to the overall complexity of development, getting knowing security is absolutely nightmare. The more developers have control over their processes, the more they just end up falling for the first thing they do at conference and add a bunch of tools they don't need. That's IT has to be careful not to let them download it. It does add to complexity. This is never a good thing to do. But at least it keeps it contained. If you know they're using a single ID and a single source of truth, you can adapt the security to around it. It's a less distributed code base. We at least have more visibility into what developers and particularly the APIs are actually doing. It encourages developers to act in a way that we can do with good practice. So that's things like API documentation. That's things like designing first and thinking about security controls then, not as an afterthought. So it does produce a different way of thinking about the problem of API security for developers. And it does kind of make security easier. Kind of. Some policies really can be implemented very, very quickly. This is from Apogee. You can see this middle column here, this is the API security policy. So you can, in a way, enable the features that you want, set up a default protection policy, and you can have the reassurance that at least that's controlled. And when you're dealing with APIs, it's not necessarily the security of the API, it's that unknown unknown. It's those issues with APIs you don't even know about that are going to cause you problems. That can be easier to find in API management than it is to find in other tools. It's kind of catching the only really need the small stuff. Now, taming API sprawl is always going to be a problem. It's never, ever going to be solved by a human being, because there are going to be APIs that aren't managed through the API management layer, because you have to rewrite all the APIs to do that. That's ridiculous. We're not going to throw away the 10-year-old code base for, just solving security problems. It's just not going to happen. It's the same way that, we didn't solve them when we had public documentation, and we didn't solve it when we had, Swagger. We didn't solve it when we had Postman, right? You only know what we know about. And the problems with APIs is often those unknown unknowns. One of my favourite stories is that because I do a lot of podcast content, I go to a lot of hacking events. And that's where they fly out from the best hackers in the world, people you've probably heard of, and me, to go to one of these events, single company. The amount of rewards there that are we didn't know about this bonus. $1,000 if we didn't even know that was public. Those get claimed every single event. There is always at those events assets the company didn't even know were out there, let alone included on the brief that they're both down to go there. And often that API is just because of the unmanageable API store. Okay, so what does it mean about hacking? What does it mean to be an API hacker now? Nothing really changes there. As an API hacker, they are still undocumented RESTful APIs. You approach them as any other API. You look for endpoints, you test whether or not they have authorization, they don't, you collect your bounty, and then you move on to another API and you do the same thing. You're still going to test your OWASP top 10 API. You're still going to test your OWASP top 10 regular. Honestly, the only thing that really changes is that the infrastructure layer is now different. But we weren't looking at that anyway. Most API hackers are looking at the API layer, looking at the logic layer. So that work changes nothing, and that really is the end of my first video. Any questions, concerns, complaints? Yeah, so at the company I work with, basically, I'm every time telling you to tell us. I said marketing and all like that. We actually end up speaking a lot to security teams whose primary concern is literally just observability. There isn't really a good way to do it, overall. There are just so many different ways APIs can be deployed. If you also have internal only APIs that actually might interact with public APIs, or internal APIs that actually don't go anywhere, they're just going internally. So actually, they're probably going to be insecure because they're only going in the company, or at least they're lower priority. And when we speak to customers and we're trying to understand what their requirements are, often it kind of starts and observability, because honestly there's no good way to actually do what API developers do, because they don't really know what they're doing. And it sounds a bit ridiculous towards API developers. I used to be one, so I am also just seeing myself. But it's just because with APIs they are so developed led. They are so led by, what the needs of the application are first, and security second, that there is no really good way to do what they're doing out there, or working. Like I said, that's how you end up at something like this, or Mono, or Salt, or whoever else. I guess Mono got bit by Akamai. That's how they kind of end up there, is they don't. So my number one top tip is new developers in general. Is you can have apps, they love it. They love it. They love the the idea of being a hacker and playing into that kind of issue. And the reason why I recommend that is I used to work at a regular company in utility broker. And when I was there, I developed probably the kind of API. I did that job was very good. The first sort of role I had was I photoshopped the CEO's face onto my leg. And at the last role I had, the last task I did before I left was to implement a full data warehousing solution, all built on APIs and all built on stuff data. But the number one thing is when I actually learned API hacking, when I was doing my first research in security, I had this horrible realization. I was like, every single API I've ever written is vulnerable to spoilers or idols or broken access control or whatever you want to call it. I never checked any security laws before I left. And I had this horrible realization. I was like, oh my god. Oh well. I don't know myself. But it's only through learning about API hacking and thinking about it from that perspective that I actually was able to connect that up into my own work. That's my first piece of advice. My second piece of advice is you have to be friends with it. If your developers are actively annoyed with your security team, if you're in that kind of relationship with very adversarial, they are never going to come to you for help. If your security department is the department of no, it's the department of makes you click on phishing links and then have to go through boring training every 2 weeks. If you have that kind of relationship, you kind of already failed surveys because they're never going to come to you for help. They're never going to come to you for advice. So making yourself available, talking to them, making sure that you're kind of supporting them, working the way they want to, but then reining them in a little bit. And the final thing is get visibility in training plans. Make sure they are got. If nothing else, and if you want to help, if they go anything, you go get a big programming book written by somebody famous, you put it on their desk, and you go, listen. You want to write dry code? You want to write this code? Is this code? I will do. This famous programmer says, yeah, it's easy to use. And it's kind of I also go do that from but it's about developing that relationship and doing more than not on the security team. I'm going to be annoyed with you. And getting away from the adversarial relationship. Those are my top tips. And also, if you want to have a go at API hacking, I really recommend you do it. It's not hard. I don't certainly maybe in this room, right? It's on my thesis as well. I knew less about security when I found my first API security vulnerability than literally any of you in the room. Because you probably have seen it TCP attacks before. I haven't. I had only ever interacted with it from the development side. So I think everyone's more than capable of doing security effective. Nothing else, kind of fun, and it's a good thing to have. I don't use any things. Really effective. So in case you didn't know this a little bit prior, it was about how this interacts with what DevOps is. So DevOps is this idea that a developer no longer just writes code, but they also get that code out on the user. And then we have DevSecOps, which is about writing the code, the finality, but also the security. Now, a lot of what that turns into is developers having a lot of control. And as we probably all know, if you give people control, they will be insecure. It is not a question of if, it is a question of when. Because security is not the fastest way to do anything, ever. It is always around about that. So my first piece of advice is one, that from a cultural perspective in developed teams, security has to be equal to usage on things like their KPIs, in their performance reviews, in their sprint retrospective. If a feature is going to be worth more than fixing a vulnerability, they are always going to go for the feature every single time. They are always going to take the shortest route to it. The next thing is to kind of work with them and let them have some control. Give them something. Whether or not like things have to be public, not necessarily, but if they just want to write like CI/CD pipelines, you just got to say yes to it sometimes. You got to say, yeah, go ahead. But we're going to also have some oversight there. And fundamentally, I think it's like way more of an organizational culture thing of how much is involved, how much well is involved, and how much like, really rein in developers. I wish I had a years, but I really don't. I know that CI/CD pipeline counting that is really successful in things like Group, where you can just have it as part of their processes. Be really helpful. And then relying on things like Jira tickets, where you can bring productivity measures that involve security as well as feature development. So that's what I got to do. So, obviously, my first suggestion is my own YouTube channel. I learned very quickly when I started making videos for the internet that you may as well recommend yourself because other people will do it. So, in terms of securing APIs and like an actual methodology, this one here, the updated beginner guide to API bug bounty. This takes a very black box approach and is the most up-to-date resource that I have. The book Hacking APIs by Corey Ball is very well reviewed. I find that for a lot of people, security is probably a bit too simple. You probably want a little bit more security complex. But the main piece of advice I have is actually have a go. Because you will learn so much more after seeing how this guy did that any book, any course, any YouTube video will ever teach you. You will just learn through like absorbing how they work. So my advice is on chapter 1 is John on a public and Tiffany chat and look at it. The OAuth API top 10 is a great place to start. But specifically, broken object level authorization, or IDOR, or broken access control, whatever you want to call it, exists on pretty much every API. Every API I've ever looked at, and that includes like the US military to like social media, to like well-known companies, have had one of these vulnerabilities. Because over the entire surface of like the site, it's really easy to see the statement. Same with broken object level or broken object property level authorization and broken sentence authorization. These are the ones that I'm most often doing with guaranteed you find them. This is when you find your I have a good one, but I can't actually make it. It's not yet anything like a major critical in this industry. So I can't talk about that one. Probably the airport one. So I was testing the system that essentially allows you to make requests for plane to land. It was designed for things like, Spitfire. When they like put together a thing of Spitfires and a fly across the sector, or what the flight people get, or like the other mapping in your players who've got that kind of thing. So it was that kind of thing you just sweat coming to a fire. And there was no pathway. Because it's kind of what pathway is, you know, for the path. And then you have to answer when you've got the pathway. How you've got a path. So you just need to do last name. So it's important to LinkedIn to look up anyone's last name. And you can see there that actually things like that. You have to give them a little effort, of course, to look around and do and stuff. And you have to tell them some information about the airport, you know, how long it is, the runway, the other way to do off the edge. You think you can edit it though by just knowing their last names. You could go and say, you know what, Manchester Airport, guess how long your runway is now? Or probably more likely Seaside Airport. Guess it's become a major international hub overnight. You can definitely land a 747 there. And obviously, like, I don't know how far it was gone, right? Like, I very much only tested this in a very controlled environment. Like, they might have pulled up the airport, but just to double check. Your runway really is long enough, right? We're not just going to fall off the edge, and kill a bunch of people, right? And you could say good. But it's still probably the most unseen vulnerability because it's just crazy that I might not say something. Any other questions? Actually, I can do a quick test for not me. I haven't seen stickers. Anybody would like